Hello, my name is Chuck Williams. I'm an architect and backend team lead with Beckman Coulter Life Sciences, and today I'll be talking to you about deploying ScyllaDB as an on-premise replacement for Dynamo. I'm a longtime software engineer, over 30 years of experience, 15 plus years of that as a software architect. My strengths are in enterprise application integration and workflow automation, business process automation. And a little piece of trivia, I started programming in Java when Java was first released as a public beta. Dates me, it's a long time ago. Today, we'll talk a little bit about the background of Beckman Coulter. We'll talk about the problem we're trying to solve. I'll go over the architecture, both the current cloud architecture and the lift and shift to an on-premise architecture. And then we'll talk about a little proof of concept project that I did to prove out the premise of the presentation. So Beckman Coulter celebrates their 90th anniversary this year, founded when Dr. Arnold Beckman of the National Technical Laboratories in California sold 87% of his recent patent that could be used for everything from water quality testing to laboratory research. The mission of Beckman Coulter Life Sciences remains unchanged today, and it's to empower those who are seeking answers to life's important scientific and healthcare questions. The mission embodies all of our efforts to help customers get the data and answers they need when they need them. The problem. So Beckman Coulter Life Sciences has a product that is currently entirely cloud-based. It's a web-based application running in AWS, and it processes data collected by the various medical devices that Beckman Coulter Life Sciences manufactures. Customers have requested that we move the system off the cloud because of data privacy issues. So we need to be able to run the application in an on-premise server. In order to do this effectively, there are many AWS managed services that we need to have replacements for. One of those is AWS DynamoDB. Our current cloud architecture, as you can see, we have web servers, we use Lambdas, we use AWS Aurora for our database, Elasticache for managing cache data, and S3 for storage of files. Everything runs through a web server fronted by an application load balancer, and there are other smaller, I'll say lesser used AWS services in play. For the purpose of this talk, we're strictly focused on DynamoDB and its replacement in the on-premise architecture being ScyllaDB, and specifically ScyllaDB operator. In doing this lift and shift, we're also moving from a monolithic web-based application to a collection of services or microservices that will be deployed in Kubernetes. On-prem, we'll be using AWS's EKS Anywhere as our Kubernetes cluster. ScyllaDB operator replaces DynamoDB. MySQL replaces Aurora. Memcache replaces Elasticache. A framework called Temporal replaces Lambdas, and MinIO replaces S3. And the goal of this lift and shift was to have to change as little code as possible to make everything work. The reason we chose ScyllaDB operator is because it is a plug replacement for DynamoDB and allows us to use the DynamoDB SDK as is to talk to Scylla. So again, find replacements for the AWS services, minimal code change to get them operational. So we didn't want to have to rewrite a bunch of code to use an on-prem service that was replacing an AWS service. The steps we took. We created a local Kubernetes cluster using kind. You can find kind at that URL. We looked to deploy a bunch of other services that are not pertinent to this presentation to the cluster. And then we set about to deploy ScyllaDB operator to the cluster. To do this, we went to the ScyllaDB GitHub repo. I pulled 3 files, the cert manager, the operator, and the cluster YAML files. The only one that had to be touched was the cluster YAML file. And this is where a lot of the research that I did into using ScyllaDB operator came into play. There are many different blogs and web pages that in documentation that talks about the steps that you need to do, but none of them were 100% compatible with running ScyllaDB operator in a Kubernetes cluster and having it work with the AWS DynamoDB SDK. So in the cluster.yaml file, under the metadata namespace entry, this code snippet needs to be added. Need to set up an authenticator as a password authenticator, use the Cassandra authorizer, and enforce authorization needed to be set to true. Then in the spec entry for alternator, you needed to set the port to 8000 and set the write isolation to only RMW uses LWT. That was the piece of the puzzle that was missing. Then as an extra step, once the cluster was deployed, we connect to the cluster, create our own user and password, and then for development purposes, we changed the randomly generated salted hash to a fixed hash so everyone would be able to access the cluster without having access to what that salted hash was generated as. So let's take a look at now using the DynamoDB SDK. So here's a code snippet from the application that uses the DynamoDB SDK to connect to our cluster running locally on my laptop using localhost 8000. It uses a credential provider of your choice. In my case, I'm using the system property credentials provider. The region is needed by the SDK, but isn't needed by ScyllaDB operator. And I override the URI to connect to my localhost. And now I have a connection in Java for my application using the DynamoDB SDK to talk to Scylla. So let's take a look at the steps of the POC. The first step being running a script to create the cluster. And here you can see the cluster being created, a control plane, worker nodes, everything's happy. The next step is running the script to install the ScyllaDB operator descriptors. So I'm installing the cert manager, installing the operator, and then creating the ScyllaDB cluster. And these are all done using simple kubectl commands to deploy these descriptors into your cluster. the result of which, and here we have all the pods running in the cluster being shown in the K9s program. And you can see down at the bottom the Scylla cluster and the 4 operators making up the cluster, all running on different workers. So with everything up and running, we can now create some tables, put some data, and get some data from ScyllaDB. First thing we're going to do is create a user. And these are the steps that I outlined earlier. Create the user with a username and password. Change the salted hash to fixed hash. And then just get that salted hash to show that we were able to change it. For purpose of this exercise, we did not have an application load balancer in the cluster or an ingress set up in the cluster. So I simply opened up a port and port forwarded from my laptop into the cluster. Once that's done, I have a program, a Java program that runs to create the tables. Same Java program can be used to put data into the cluster. Notice here that we're testing put and get. And then I can get the data from the table, and an unformatted JSON file comes back because that's what was put into the table. And all of these were done using the AWS DynamoDB SDK in Java. Finish up with a little quote. There's a way to do it better. Find it. From Thomas Edison. Here's where you can find me. My email address is cwilliams011@beckman.com. My GitHub is cwilliamsnh. And my LinkedIn is cbwilliamsnh. Thank you for watching.